everyone. My name is Amy Fiala. I'm with Koehl Architects, but I'm also a board member of New York Passive House. I've been a board member about 4 years, and just to say a little bit about who we are, our mission is to promote awareness, understanding, and application of the Passive House standard through education, events, and advocacy. And we're focused on professionals, policymakers, and the general public throughout New York. And we just like to work together and help spread the word of Passive House, which is why we're here today, co-hosting with the Accelerator. So today we are gearing up to hear a presentation about a really awesome project from Handel Architects, and Koehl will be doing that presentation. So Louis, why don't you take it from here and tell us a little bit about yourself as well.
All right, I'm Koehl. I'm the Director of Sustainable Design at Handel Architects. Thank you for inviting me here. We're always excited to share our work with organizations like House Accelerator and New York Passive House. We've presented some other projects with both of these organizations in the past, so I don't think we've shared Winthrop yet, and this is definitely a more detailed look than I think we've given in other places, so that's exciting. And yeah, I've been working in Passive House buildings at Handel for the last 5 years, starting with the Cornell project, and then primarily with Sendero Verde here over the last 5 years, and a little bit here at Winthrop and our other projects. So I'm excited to share this with you. And we'll go ahead and jump in. So as I said, I'm Koehl, and this is the project here. It's Winthrop Center, and you can see it's on theme, INFILL. It's kind of nestled right in the middle of downtown Boston here. The team, the developer is Millennium Partners. Obviously, Handel Architects is the engineer. The architect, WSP is the engineer for MEP. D. Simone is our structural engineer. Stephen Winter Associates is our Passive House consultant. And then Vidaris, now Socotec, was our exterior wall consultant, and the contractor is Suffolk. And it's a very, very large building, almost 1.8 million square feet for the whole project here. About 800,000 square feet of office, and that is the Passive House certified portion, or the portion that will be Passive House certified. And we'll dive into more details into that as we get going. There's also 317 condo apartments. That's at the top of the tower here. So you have the condos at the top and the office in the middle. And then there's a really extensive public programming at the base, which we'll take a look at, and a lot of amenities for the office users. So, you know, the primary use groups, residents, the public of Boston, and then obviously office tenants. So the project is located certainly an infill site in the middle of downtown Boston, just east of the Boston Common. And you know, it's pretty dense area, and largely you know, a lot of sites have already been built on. There's not a lot of open sites in this area. And we had a unique condition with respect to the Boston Common. There's a state law that limits the amount of shadow that can fall on the Boston Common at any given time or throughout the course of the year. So we had to do kind of an extensive shadow study on our project to determine how much shade we would be casting on the Boston Common, which doesn't really have anything to do with Passive House, but is kind of an interesting infill challenge there. It was certainly a long process. We had to build our own parametric tool there to analyze, basically break up the common into these squares, and then analyze how many of them were receiving shadow at any given time. The site was a 2-story parking garage. It's nestled in between these two much larger office towers. To the north here, we have 75 Federal Street, which is like an Art Deco tower built in the late 20s, early 30s. And then to the south, we have this 1970s office building, 100 Summer. And then let's see the next one here. So the other kind of context piece here was this 133 Summer Street, which is a Paul Rudolph building. Interesting old building. A lot of people in the Boston architecture community were trying to get this building landmarked, so that it couldn't be removed. There was an earlier iteration of this site that didn't involve Handel Architects. This was 20 years ago. That involved tearing this building down, and that is obviously not something that the community wanted. So our project, when it came to be, our site ended up taking a form, kind of a T form here, and that is with respect to all the adjacent buildings. Interesting pieces of the site here. There's a small park that is existing, but it's being completely renovated and redesigned as part of the project here, Winthrop Square Park. This is Winthrop Lane, which is a little kind of meandering road that gets you over towards Boston Common. And we really wanted our project to be, rather to be a connection from the Common kind of through this kind of meandering pathway towards the financial district. So, with the parking garage that was on the site originally, you were kind of interrupted along this lane, you kind of had to walk around. So we wanted to pull people through the park and through the project. And we did that with this piece here called the Connector. To the north of the Connector, we have our residential lobby, and to the south, we have our office lobby. So then this is just some images of, this is a photo of the kind of east portion, the east volume. So that's this little kind of portion here, under construction. And here's the way that fits into the site itself. So you have the taller version of the tower here, with the office stopping around the same height as the adjacent buildings, and then the residences above. This created some really interesting floor plates for the office, and kind of a diversity of spaces, which we'll get into here. Program-wise, residences at the top, these are condos. They're going to be LEED Platinum. In the middle, we have our office program. This is the program that will be certified passive house. It is core and shell, so there will be no tenant fit out. So a big challenge there was figuring out how to work with future tenants and, within the passive house certification. So this, the passive house certification for core and shell office is not something that was already in existence. It's something that the Passive House Institute wanted to develop, and this project is kind of a pilot project for that certification pathway. So this will be the first time it's done. And then we have these amenities and meeting rooms as kind of part of the podium, and then they have the big connector here, which is a triple height space in the back. This big front door here in our lobbies. This is just a view of the connector. So it's this big triple height space. There'll be retail, there'll be food and beverage, and this really active, engaging space for kind of draw people through the building and really make the building a piece of the Boston streetscape, and not just a big obstacle that sits in this infill site and prevents anyone from getting around it. And this is that space under construction here, just to give you a sense of the scale. Very, very large space. This is looking back towards Winthrop Square Park, and this is looking towards the financial district. You can see, these kind of very tall office buildings on the east side of the site. This is our big grand front door here. This is the Winthrop Square Park that you travel through, and this is the kind of gateway to the financial district here. Residential lobby entrance, and then the office lobby, you actually enter through the connector. So you go into the connector, then you take a right into the office lobby. And this is that front door under construction. There's this very large limestone clad column that will be installed here. And just looking at the building, just giving a sense of the scale and the height of the building adjacent to its neighbors here. So now we'll kind of dig into the office program and kind of focus there for the most part, as that is the Passive House certified space, and this is a Passive House presentation. Office space, Class A office space, we wanted to make sure that it was, a big driving goal of the development team was to have a lot of natural light coming in here, big tall windows, floor to ceiling glazing. And these are all things that, you don't really equate with passive house. So a big challenge was, how do we figure out how to get the amount of glazing, the amount of light to get the kind of atmosphere that they want inside the space while still meeting the passive house goals. We'll talk a little bit about that. And then they also, they wanted this space to be adaptable, to be flexible. This is kind of, if you're kind of in the center of the T, looking back towards the Boston Common here, we have these zones within each office floor that for knockout slabs. So if a tenant wanted to take multiple floors, they could punch through and create a connective stair. And this, I include this just to kind of say that we have no idea who's going to take these spaces. These spaces are ultimately going to be tenant fit out. And that's just kind of a unique challenge that we hadn't dealt with in any of our other large scale passive house projects. I'll talk a little bit more about that. Obviously, the goal, there was this goal from the very beginning here with this project of it being the most sustainable office building in Boston, or trying to be the most sustainable office building in Boston. And that's in line with Millennium Partners, Handel Architects. We try to be forward thinking with our work here. And Stephen Winter, of course, driving that as well. And, we see the writing on the wall here. Codes and policies are changing in all the jurisdictions that we work in. None of these local laws and energy code updates that are kind of being shown here were in effect in 2015, 2016 when we started this project, but you could see that it was getting there. And that's especially true in Boston. Boston has a variety of, I won't go through all this, but they've got a variety of different ordinances, local laws, and programs to reduce the energy use of buildings. The big one is this Berdo here, which is the Boston Energy. Unfortunately, my my Zoom thing is covering what that says, but it's it's Berdo. You can see it, I can't. But this is a program that's really driving carbon emissions down in a step-by-step tier as every 5-year period here. And so that was something that, as they were looking at developing the building, and as Millennium's looking at operating this building into the future, they really wanted to make sure that we were building a building that would comply with this, decades into the future. So we always ask this question when we give these presentations: why passive house? And a lot of times we're giving similar answers here. Of course, improve the health of inhabitants, superior thermal comfort, reducing energy is of course a big one, and carbon emissions. But here another big one was easing compliance, easing long-term compliance. So understanding that this building is there may be emissions penalties coming in the future. We see that here in New York as well with Local Law 97. And we want to build a building that is, from day one, will perform in a way that is not going to accrue any of those penalties. All right, so how to achieve a passive house. If you're on this call, you likely know most of this, but we focus on enclosure, we focus on MEP systems, and then of course there's the verification protocol there at the end to make sure that everything that was in the design documents is, or everything that's constructed is conforming to what was in the design documents, and that will actually see the performance that was modeled in reality once the space is complete. We have several large-scale passive house buildings. This is the first one that we're doing that's not multifamily residential. So that the House at Cornell Tech, Sendero Verde, UTSC, those were all residential. UTSC is a dormitory. The house in Sendero are more kind of traditional multifamily. The house is graduate student housing, but it's a similar to kind of micro units. But Winthrop Center really is completely different because it is office. It's a whole different program, and so that was something that we were very excited to tackle with our partners and with Passive House Institute. One thing that's unique about Winthrop is the certification boundary. So up until this point, whenever we had done a passive house, the entire entire building would be included within the kind of airtight envelope, and the entire building would be tested, blower door tested at the end. So even in an example like Sendero Verde, where we didn't certify the community partners down here in the podium, but we did include them in the envelope because we wanted them to have that benefit. It also made the blower door testing, it just simplified that process. But because Winthrop is so large, it was just not something that was possible. So there were challenges with creating airtightness between programs as well as with our exterior wall. And you kind of imagine the office program kind of as an infill within a residential tower. That's kind of a vertical infill. So how does this compare from a facade standpoint? So here's Winthrop here. It is a curtain wall facade, a triple glazed curtain wall, and it has roof of R30, a little lower than our other projects there. The walls are 18 effective. The glazing is 0.22 U value effective. And the big thing here is 45% glazing. So we, through a series of working with Stephen Winters and kind of really studying these different variables, we were able to achieve 45% glazing, which is not quite as high as the developer wanted, but it is very high for a passive house. And you'll see here that some of the infill aspects of the site actually helped keep that number relatively low, or made sense to keep it a little lower than what their target was, which would have been closer to 55 or 60%. This is another point of comparison here for this project to our other projects, looking at the energy budget. You can see the energy budget here is a little higher than our New York projects. That is partially driven by the climate zone, but it's also largely driven by the density. This building will be much more dense than our residential buildings, and that was something that we had to take into consideration, and we were able to factor that into determining the energy budget for the project. So when we think about energy budgets at the beginning, when we're setting these variables with Stephen Winter, the three primary things we're taking into account are the climate zone, the building typology, and then now density, which density is not something that has always been taken into account. As I understand, it's something that more recently has been added to this kind of calculation because of these large scale buildings and the impact that density is having on meeting those energy demands. This is a test fit of Winthrop. So we did a series of test fits for the building to try to determine some assumed occupancies. Ultimately, as I said earlier, there's not really any way of knowing for sure how these spaces will be utilized, how many people will be in them, what the internal loads will be, how many computers. So ultimately, Stephen Winter had to take certain assumptions and use those assumptions, even though, understanding that down the line, when tenants actually move in here, they may be more or less dense, there may be more or less computers, but we had to kind of pinpoint assumptions to kind of work from. This is just an image of that open space here under construction. So this is looking back towards the it's kind of standing here looking back into this deep space here. So you can see really a lot of glazing, very open floor plate, and this is speaking to that assumed tenant energy demand. So there was kind of a calculation that had to be done. How much is the base building energy demand? How much can we assume the tenant energy demand is, and what kind of falls in those categories? In the base building, we're looking at envelope performance, the HVAC system efficiency, the ventilation, and then tenant loads. You have the density, the office plug loads, the lighting, and then ventilation rates. Based on those demands. And ultimately, the modeled reduction in energy use for this building from a Boston commercial office building that would be built. This is LEED baseline. I think I need to confirm what that baseline is, but I believe this is from a code minimum office building in had it been built, had construction started in 2018 in Boston. So it's a 32% reduction. You see the biggest place where there's a reduction is in space heating. That's largely due to the energy recovery ventilation and obviously the very thermally efficient facade. But you can see how that really drives up plug loads as the major demand driver once we reduce this. And this is a challenge to future emissions reduction, and it's one that architects really will struggle with. It's much more of a behavioral thing. So there's that'll be an interesting thing to see how that works in the future. And ultimately, the site EUI for this building is around 28. And average site EUI for Boston office buildings that are currently existing is around 64. So we're over 50% reduction from the kind of office stock in site EUI. And comparing that to New York City, we would be in the bottom 10% of energy users here. So definitely less than 30. All right, so we're going to talk a little bit about the facade. This is, obviously a major design driver here. As I said, we wanted a lot of daylight, floor-to-ceiling windows, really spacious, capture that kind of Class A office tenant. And this was a challenge both from the passive house requirements, but also for an infill site, because as you saw, the office portion is only about as tall as its office neighbors to the north and south, and these buildings are relatively close. So we have this kind of primary west-facing facade that is very open, and then we have this volume here at the back at the kind of east and south of this volume here that's pretty open. But a lot of our kind of northern and southern exposures are pretty obstructed by these adjacent buildings. So that's obviously a challenge, but it also helped us balance the overall glazing percentage because we could really load the glazing up at these kind of most critical places and then have more opaque wall here, which to some extent was driven by fire code anyway. And that helped us kind of lower the losses at the facade. We ultimately chose to go with curtain wall. As I understand, we did study a mega panel system here, but it was just not something that made sense for this site, partially because of the amount of glazing and then also because of just site constraints of installation. You can see how challenging and constrained these facade installations will be, especially here on the south side. So ultimately, we have the enclosure is triple glazed. There's double OE coating, I believe on the 2 surface and the 5 surface. And the overall U value here is a 0.22. Center glass U value of 0.12, and an SHGC of it ranges between 0.3 and 0.33. And the way that we kind of kept this facade efficient is to have the right kind of balance between the spandrel pieces and the vision glass here. And that looks something like this. So this is a typical slab edge detail. The airtight layer, the curtain wall is of course airtight, but once you get into the spandrel, we had to bring that airtight layer back to the back of the spandrel because this gets very hot, and we needed to make sure we were able to drain any condensation, or this could weep and vent either the hot air and also any moisture that were to get back there. So we are bringing the line of air tightness back to the back of the spandrel panel. The mullions are 12 inches deep. We have 9 inches of insulation, mineral insulation in the spandrels, and then some additional insulation at key locations here. A big point of challenge was the stack joint here. It's kind of being shown in this detail cover, but it is actually not covered. We weren't able to cover the stack joint, so with additional insulation that needed to remain exposed. So that is, the worst performing moment of the system overall. Oh yeah, here's an image of it. You can see the stack joint here, and you can see the gasketing. Yeah, so all the mullions are thermally broken. There's gaskets at the vertical joints between panels. We had a lot of these corners and kind of very slight angles that were a challenge. But we tried to keep things from, we tried to minimize any 90-degree angles or very sharp angles, to improve the facade performance. Just some images of some therm models that were done for the mullions. You can see that insulated spandrel panel here. All right, so as I was saying, the different facades that would be treated slightly differently. So for example, in the back of the building here on the east side of the building, this was one of the most open portions of the building, and it's very visible from the street. And we really wanted this to be a space where we had, very tall glazing. So here we had very limited spandrel. We did this kind of zero spandrel detail to really make it appear that it's glass all the way up and down. And this was obviously a place that we invested a lot of our budget there for glazing. For you had to be offset by opaque wall elsewhere. And here on the north and south side of that volume, we have these fins, which was a slightly different effect, and a little bit more opaque wall here. Some of that was driven by the fire code and the proximity to the adjacent buildings. And then some of that is obviously just trying to start to slowly reduce the overall amount of glazing. And then the primary facade wrapping the building is this pleated wall, which varies in density in terms of opaque and transparent as you're going around. We really focused on maximizing the transparency on the west side. We are looking out over the park, you're looking towards the common, really beautiful views this direction, and making more opaque wall on the north and south sides. And this is some details of that. Oh, it's a missing image. And then every office floor has a terrace. The terrace is thermally broken with a Halfin system. And obviously the terrace doors are always a challenge with a passive house project, but we had to account for those in the model. Detail of that. This is a good image looking back towards the common. The curtain walls were, of course, fabricated in the shop, so there was a lot of quality control, and we had mock-ups and your performance mock-ups to make sure all the performance criteria was verified before installation. The installation process here was really interesting. They used called a monorail system, a spider monorail system. So they created this rail here, and then at the beginning of the rail, they would pop the panel onto the rail, and then it slides along to wherever it needs to go to get installed. So they're not, rather than, in some locations, they're raising them up on a crane, but for the most part, they're landing all of the panels on the floor, and then from the floor, attaching the rail and mounting them. And they were able to do, in some instances, over 100 panels a day with this system. It was a really rapid way to get this installed. Some other images of the curtain wall installation here. Another missing image. And we have, this is a view of the inside of the curtain wall. You can see we have these moments where there's additional mineral wool in here. So, trying to just add as much opaque wall insulation as we can at the places that are most critical. And then these are the vertical panel joints here. When not in the kind of zone of glazing, we wrapped those in mineral wool insulation and foil faced and kind of taped all that up. So all that'll be hidden behind a sill. Okay, we don't have time to talk through. Okay, so we'll jump into looking at some of the HVAC systems here. So the office building, again, is in the center, and you have the residential tower on top. There is this large mechanical transfer floor in between the two programs. And then there's additional equipment on the roof serving both programs. And then down here you have the podium with the connector and the amenity spaces. At this intermediate floor is where we have our ERUs for the office. It's also where we have our chiller plant and our boiler plant to provide hot and chilled water to all the floors, all the office tenant floors. We're using high efficiency condensing boilers. We did look at a all electric option here, and I'll touch on that here in a moment. But ultimately, we are using natural gas, high efficiency condensing boilers here to produce hot water, and then high efficiency magnetic chillers for the cold water production. And then, of course, we have a centralized ERU system where we have a series of risers, and these you'll have different locations where tenants can tap into these. So during your tenant fit out, you'll have points of exhaust and supplier delivery, and the tenant architect and MEP engineer will figure out how to circulate that around the space. That's of course true for the hot and cold water as well. There'll be points where you're tapping into that system. And this is just an image of it's not a very good photo because it was very difficult to get a good photo of this thing. So it's massive. But this is the ERU for the office building on the floor. There's all this other equipment kind of around it, but just to give you a sense of scale, how big these ERUs are, they're really, really large. And we looked at a variety of options for heating and cooling for the tenants. Ultimately, we are so we're providing hot and cold water with the intent that tenants will use fan coils. Those fan coils will be need to be ducted to the perimeter to kind of wash the glazing because we are not, because of the size of the glazing, we're not meeting thermal comfort criteria with the glazing alone. We do need to, the tenants will be required to wash that glazing. But we also looked at chilled beams. We looked at underfloor air distribution system, and then we looked at water cooled VRF. This would have been our all electric option had we have gone that route. All of these had various pros and cons. Fan coils, ultimately they were, the fan power was very low. They were lower cost for tenant installation. They're very efficient. There's a lot of flexibility there. So that kind of weighed or outweighed all the other options there, made the most sense. We did look at a VRF option, looking at what would how much space on each floor would be required for these VRF condensers. This would be a water source VRF system, and we did a layout showing these VRF rooms. Obviously, a lot of space on the floor for this, so you do lose a lot of leasable space. Also, a lot of refrigerant running around. There was several reasons why this was ultimately not selected. Here's some sections of the different options. Underfloor air distribution, you can see this would have been an interesting option. It would have raised the floor, so it would have given a greater sensation of kind of floor to ceiling glass. And air distribution at the floor is a very efficient way to do that. Chilled beams. This would have had a very strong visual impact on the project. These things are large and hard to miss when you're looking at the space. And ultimately, we went with a fan coil system where the unit can be ceiling mounted closer to the core and then ducted out to the perimeter. So the way that this project is a little bit different than our traditional passive house buildings. We are not testing the entire volume all at once. We are testing, we're blower door testing each individual floor. So they are, and they're in the process of doing that now. Several of the floors have passed. We still need to hit that same target, that 0.6 air changes per hour at 50 pascals that we're all familiar with. That is still the air tightness requirement. As I understand from Dylan Martello there at Stephen Winter, we've been hitting close to a 0.5 on most of our floors. So a little bit higher than our other passive house our Cornell project was at like 0.15, and Sendero we recently passed at like 0.45. So 0.5 is a little higher, but still below the threshold. And so each of these floors is completely compartmentalized from the floor above. So that was another important element here. We looked at different ways of doing that, whether or not, you know, it made sense for all of this to air to be able to kind of transfer between all the spaces. But ultimately, because of these different tenants and all the variables there with tenant fit out and how that was going to work, the direction is to have each individual floor completely compartmentalized from the floor above. The most challenging point of that is the core. So at the core, we are required to have doors that seal. So you'll get off on the core and you'll have to go through a doorway to get into the office space. And so that is when we're testing these floors, we are testing with these doors installed. And then, or not with doors installed, but testing with this sealed as if doors were installed. Those doors, I believe, will ultimately be provided by the tenant. I don't think those doors are base buildings. That'll be within their design, within the tenant architect's design. But there will be certain requirements for them to meet a certain performance criteria there for those doors. Yeah, and then you have your different ducts, and obviously all those will be aero sealed, like we do on all of our jobs. Which is a very effective process. And there were several smaller tests done at different points to make sure that we were kind of on track, just with certain segments of the curtain wall. Some of these are actually images from other projects. These are not all here at Winthrop. Oh, here you go. So, chamber tests for certain sections of the curtain wall to make sure that, oh, this is not Winthrop either. This is a different project as well. But this was done at Winthrop. All the ducts are filled with AeroSeal. AeroSeal is like an aerosol sealant that's sprayed up into the ducts when they're pressurized, and you fill the ducts with the sealant, and it finds all the holes. And you can see just the massive drop off in leakage in the ducts. This is CFM leakage. Before the AeroSeal install, they blow it in and they continuously test to see to slowly watch it drop as the sealant takes hold in all the various different cracks and crevices of the ductwork. A much more effective system than going and mechanically closing and patching all of the ductwork penetrations. Yeah, and this certification is a pilot project. It's, so they are following the same requirements for certification that our other passive house projects are doing. We're looking at thermal bridge documentation, verification of required airtightness with the blower door test that I just talked about, commissioning of the ventilation, and making sure that you're within that 10% balance between the exhaust and the supply, and then of course the maximum source EUI. And the big difference here is that maximum source EUI, all those other items are kind of tested regardless of tenant fit out, but that building energy consumption is ultimately based on assumptions about what kind of tenants we'll have in here. And to guide those assumptions, the Millennium has put together a very robust package of kind of tenant lease requirements, things that tenants need to do in their fit out to make sure that they are meeting the performance expected. Yeah, so thinking about cost, there's obviously several premiums for going this direction. There's the additional testing, additional time for all that testing, and for some of the other quality control measures. Cost for temp enclosures to do the testing. The curtain wall was, of course, more expensive, being triple glazed and thermally broken. And so that's, and then obviously the mullions were deeper to allow for the added structure needed to support that very, very heavy glazing. There's some additional mechanical costs, the aero sealing, increased condenser water pipe sizes due to efficiency requirements. And then that last one, this, tenant work, more stringent requirements such as floor-to-floor penetration, ceiling and floors on LMP systems. So, all the ceiling and compartmentalization of each of the floors an additional cost. It's not something that's typically done in a core shell office building. But all that premium comes with significant benefits to the tenants. Tenants will have taps for a very efficient system. That energy recovery is going to help reduce their utility bills, and obviously the high performing facade will also help with that. There's a lot of flexibility built into this because there's taps coming off at 4 different locations, so they can provide distinct zones. Gives them a lot of flexibility with how they want to lay out their space. There's an additional fresh air included on each floor, and that's assumed within the energy budget. And there's no premium charge for after hours HVAC usage, which I guess is common in offices. And that's not necessarily a factor of the passive house. That's because this is a multi-use building and there's redundancies between the residential and the commercial program. So we're increasingly getting kind of in closing here. Where codes are getting increasingly stringent, and the goal here of developing these large scale passive house for us and our clients is to get ahead of that to get ahead of that transition and really to ease that transition. I mean, this graph here showing these jumps. At 5 year you're gonna, or every 5 years you're going to need to get a little bit higher performing. The goal here is to start some of this effort earlier, so that the design professionals, the contractors, the tenants, people can start to understand what these changes mean at a more gradual pace, and we can drive the industry forward in a way that's not quite so aggressive at these kind of key moments. And then there's a lot of benefits to passive house. It is a pathway to zero carbon. By driving that energy demand down, we are making it easier to electrify the building. Even though we were not able to do that here, it would be a lot easier to electrify a building like this because that electricity demand is so much lower. And then, of course, the compartmentalization also comes with COVID safety. You don't have to worry about what's happening on the office floor below you. Then better acoustics, better thermal comfort, all the typical advantages that we see in passive house buildings. And so there is the kind of final rendering there of the project nestled in its infill site. You can park in the foreground and the big front door, and it's well on its way to completion. We will have tenants occupying these floors here by the middle of next year. And so thank you. Happy to take any questions.
So we can move into the Q&A session. So and thank you again, Louis, for such a great presentation. It's really great images and exciting to see it develop. So the first question that came in the chat was from Jean. So Jean, if you would like to take yourself off mute and ask the question, otherwise I can read it for you.
Would you go ahead, Amy?
Sure. So Jean's question was, is the ERV variable flow? And if it is, how do you determine the volume needed at any time?
Great question. I do not know the answer to that. I would assume that it is variable flow, but I'm not sure. I'm not too keyed into all the various nuances of the mechanical system of this building. I'm much more familiar with the facade. So I will try to answer the questions as they come up. And if there is anyone on the call here from Handel that worked on the team that does know the answer to these questions, please feel free to chime in. But I'm sorry, I don't know the answer to that question.
That's all right. So moving on, and hopefully I say everyone's name correctly. Louis, I think I said your last name incorrectly at the beginning, so sorry about that.
That's okay.
I said Koehl instead of Koehl.
It's a
I'm
common
sure that's
occurrence.
a common, yeah.
Yeah,
But so to going on, I think to Huston is next, and hopefully I'm saying that right.
Actually, it's Houston, but
Houston,
thank you.
okay.
Thanks. I'm just curious, given Handel's extensive experience with residential passive house, how was the decision made not to make the residential portion of this tower also passive house? Seems kind of weird.
Yeah. I mean, it's ultimately it was ultimately an owner decision. The product they were looking for in the market is a very high-end condo, and they needed a lot of glazing, and we were not going to be able to achieve that glazing percentage that the kind of market demands there with a passive house building. There are some other there were a few other decision makers, but that's really the primary one. So the residential is LEED Platinum. And there are, it does take some advantage of some of sharing redundancies with some of the passive house systems, and it is of course the same curtain wall manufacturer going all the way up. So there are benefits that were driven by sharing the same volume, I guess, as the passive house office. But ultimately, we were not able to get to a place where we thought we could certify that.
Louis, can I chime in as well? I had a chance to interview Brad Mahoney a couple months ago about the project and asked exactly the question that was just asked. And in addition to what you just mentioned, this was also the way he talked about it was this was a question of how much they could really bite off and chew with passive house, because at the point that they were making the decision to commit to passive house a few years ago. And at that point, really, doing a roughly 800,000 square foot passive house project, which is what the office represents, was massive compared to what else had been built. Even the, I mean, I don't know how big is Cornell Tech, Louis? It's significantly smaller.
Yeah, 270,000 square feet,
right?
Or 278.
Right.
Yeah.
So the way that he talked about it was that it was just they felt like they were taking on a big challenge, a lot of new stuff, and that's what they could do now, but that perhaps the next project would be different. So I think it's part of and Hans, I appreciated your transition question, but I think it's part of that transition. Anyway, just wanted to share those thoughts from Brad.
Thank you, Zach, and thank you for that question. So next up we have Noah.
Yeah, hi. Thank you again for the presentation. Hopefully you can hear me with a little bit of background noise. I was just going to ask, the glazing was clearly a big consideration with this project, and how high your glazing percentage is impressive to the passive house standard. Did you consider anything like dynamic glazing or other types of glazing that could have, increased that threshold while still achieving that level of efficiency?
Yeah, I know that dynamic glazing was considered. I don't know what ultimately drove that decision away from dynamic glazing. We have used that in other places where we use that on a project that we did with the Durst organization in Queens, which we found it to be effective. So I'm not sure why we ended up not going with dynamic glazing, but I think that it is already a very expensive piece of glass with the three panes and 2 low-E coatings. And then the other thing I think is Stephen Winters is making sure that like the SHGC is very critical. They really want to make sure that they're tailoring that heat gain correctly. And I'm not sure how, I was not involved in the kind of early stage of this decision-making on this project. So I'm not sure how that played in, like how dynamic glazing actually plays into that passive house model, how they model that and how that impacts their SHGC assumptions. But ultimately it was something that was thought about, but not decided to go with.
Great, thanks.
Thank you for that question, Noah. Next up on the list, we have Barry Stevens' question. Barry, if you want to go ahead.
Thanks. Yeah, those that know me, it comes to no surprise I'm asking about the ERVs. a scope of that, a project of that kind of scope, there's nothing out there that's, passive house certified to that size and so forth. So what was the process to get that, and what kind of efficiencies were you able to get with what you settled on?
I know they aren't passive house certified, and I know we took I guess, passive house makes you take that kind of 5% hit on the stated efficiency when you don't have a passive house certified ERB. So I know we took a kind of deduction on whatever the stated efficiency was. I want to say that the efficiency was somewhere in the low 70s, but I'm not 100% sure. I would need to verify that with Dylan. It was not as high as what we were getting on with using our Swagon units on Sendero Verde. I think it was closer to what we were getting with our Aon units at Cornell, which I think was high 60s, low 70s.
Okay, great. Thank you for that question, Barry. Next up on the list, we have Adi or Addie. I'm sorry. I'm not sure if I'm saying that right, but go ahead. She said, it seems like Handel Architects has been involved with this site for a long time. You had mentioned a previous scheme from 20 years ago. So I'm wondering at what point the developer committed to partial passive house certification and how that discussion process worked. Who is pushing who, et cetera? What sort of financial value does the developer see in passive certification? So a lot of good
Yeah, so
questions there.
we were not involved in the earlier, at least not to my knowledge. We were not involved in the kind of the much earlier iterations of the site. This site has been something that's been talked about in Boston, I think, for quite a while. We worked on a design competition for this site in 2015. And I think, as far as I'm aware, that was our first kind of foray into looking at the site. There may have been something that happened before my time that I'm not aware of. But it at that point, with that design competition, it was not passive house. And I think, and Zach, maybe from interviewing Brad, you might be able to speak to this a little better, but I believe it was largely, I mean, we had, but once we had this, we did the competition. I think there was someone else won. Ultimately, that didn't work out, so we kind of did it again, and then we went and Millennium's kind of bid won there. Millennium has a long relationship with the city there, and has successfully, built some very large projects that the city appreciates. And so ultimately, Millennium was chosen, and I don't know when passive house came into play, but at that time we were right in the throes of building the Cornell building. And I think that, as far as I'm aware, it was very much driven by the developer and their interest in, both being a forward-thinking partner in the fight against climate change, but also looking out at what the market might want in 5 and 10 years, and saying, we're seeing an increasing demand for sustainable product and for kind of healthy work environments, and this is maybe a pathway to do that. And so they started to explore it. I don't know, Zach, is there anything that?
Yeah, no, that's exactly my understanding. Brad also shared that they early on, a kind of a group from the project team visited Belgium and did some fact finding about big passive house projects. And there's also, I'm forgetting the name of it, but a famous office building that recently went up that's super sustainable somewhere in Belgium. And so they were, also visiting that building and understanding, what were the moves that they could make to really create a special environment for the office tenants. So definitely, I think it's like the vision of the developer that was really driving the decision, which is pretty awesome.
Yeah, absolutely. And I mean, I think this passive house, just in the few years that we've been involved in it, I think we, at the beginning, everything was very focused around energy efficiency, and more and more, especially with COVID and work from home, and the idea of healthy living environments, better thermal comfort, better acoustic quality, like living in a space that is more comfortable and gives you a better sense of well-being and healthier, especially when you combine it with some of the kind of material like off-gassing limitation or restrictions with like things like lead, and this is also this product as well. So I think health is becoming much more of a selling point for these buildings. Of course, the fresh air as well.
Yeah, it's very exciting to see it come from the developer side. So thank you for that explanation. Next up on the list, we have Chris Hahn, if you're still here, if you'd like to speak. Chris might have left, so I will.
I see Chris on the list, but
okay.
But yeah, why don't you ask it?
I can fill in. So Chris says, can you provide more insight into using condensing boilers versus electrifying?
Can I? I'm not sure I can. I know that the VRF, it took up more space on the floor because you needed these closets. Whereas with the condensing boilers, I mean, when you have a hydronic system and you're running the water, just throughout the building, you're able to do things like chilled beams. You're able to do things like fan coils. All that stuff can be installed in the ceiling. You're not taking up leasable floor space. I imagine that was a big part of it. The other thing is there's redundancies between your domestic hot water and the domestic hot water being used in the residential towers especially. So I don't know this for a fact, but I would imagine that there are some purchasing benefits to going that route when you're building a building that has both residential and office components.
And I'll bet, I mean, not to speak for MP Boston, I certainly cannot do that, but I'll bet you that they're looking at cracking the all electrification nut, on future projects. I think partly there's just these are multi-year projects, right? And so you come up with some solutions in one kind of context where there are certain equipment that's available, certain priorities, and I think that the priorities, I think, in the sustainable building community have shifted and more and more toward all electrification. There are probably more solutions available. So I do think that what we're witnessing here is an evolution.
Yeah, I think that's definitely true. I mean, these decisions were made, 5-6 years ago, even in some cases. So there's the environment has changed a lot, both regulatory and what technologies are available and the cost of them. I mean, just heat pump technology is so much more readily available. So I think there's definitely more electrified solutions. And if they were designing this building today, I would, as Zach said, I don't want to speak for them, but I would venture to guess that they would go very heavy at an all electric option.
Yeah, it's amazing.
We've got 3 minutes left of Lewis's time, so I think we probably have time for one more question, and then we'll wrap it up.
Great. So Denise is on the list next. Denise, would you like to speak? If you're still here.
She signed off. Yeah, she said she sent her regrets. Yep.
Great. Okay. So could you confirm how certification is happening prior to the fit out if thermal criteria is not being met?
So that is a good question. So they're certifying the core and shell space. So they're certifying the base building. And then part of that base building, there is this kind of tenant, these tenant requirements that are built into the lease. I don't know exactly what's included in them. And I know that's been an ongoing conversation. And, of course, in the middle of this, we had a pandemic where a bunch of people stopped going to the office, and there was a bunch of concern about, what it means for a new office product and what kind of tenants are out there. So I'm sure there's been a lot of pushing and pulling on what those tenant requirements are, and discussions with Passive House Institute about how that's going to take shape. but they are certifying the core and shell space. So I don't know exactly how that statement is being made that, that the glass will be washed with heat, but somehow they're figuring out a way to get through that. Dylan would be able to speak more to that at Stephen Winter.
Okay, great.
Yeah.
Thank you.
Thanks, Amy. Awesome job on the Q&A concierge role.
Thank you, Amy.
Yeah,
Yeah, no,
and Louis,
of course.
this is really great discussion, Louis. Thank you for your answers and for the really wonderful presentation. We're super excited about the project, and so it's fun to dive into the details in a way that, I mean, it was really detail rich, which was really super cool. So on behalf of Passive House Accelerator, thank you, and I'll hand it to Amy.
Yep. Thank you very much, everyone. Thank you for being here, and we hope to see you at the next one.